Okay, so it's already noon, so I think we can start.
Yep.
Good morning and welcome everyone to our first online webinar for dental technicians. I'm so happy and excited to welcome all of you today. As our moderator for today, I'm totally delighted to welcome one of our most important key opinion leaders, Professor Tomas Linkevičius from University of Vilnius. And our key presenter today is one of the most talented and humble guy from Poland, dental technician, Mr. Arkadiusz Piątek. So a very warm welcome to both of you.
Hello, hi.
Hello, hi.
More cheerful, guys, applauses.
Okay, make some noise.
Let's not keep our participants waiting, and the stage is yours. So, Thomas.
Yeah. Hello, everybody. Thanks for nice introduction. And of course, I'm just today a small part, and my task will be to introduce Arkadiusz, where he will talk about his excellent work and topic. However, before I do that, I'd like to again little bit emphasize actually why we are meeting here. And actually the situation in the world has really changed and pushed us more to online education, which we find more and more actually exciting. And there is a lot of discussions among speakers in the world that even after, let's say, the pandemic will be over, because it will be over at some time, some of the lectures and some will stay online even after the education, after the pandemic, because it's really a cool thing to interact and to learn like this. So I'm really excited to looking forward to the lecture, and Arkadiusz, the stage is yours. Please start your nice presentation.
Okay, thank you very much, Thomas and Rolandas. Hello, everyone. As you know, my name is Arkadiusz Piątek. I live in Poland. I was born here, and almost for about 20 years, I'm running my private lab. And also, almost from the beginning, we are making implant-supported restoration. And I would like to share a little bit of my experience and show you a few cases why I think that we as our brand group dental technician, we are sometimes the key factor for zero bone loss. We can find some mistakes or create some mistakes. Very, very often, we as dental technician, we get impressions or traditional impressions or optical impressions, which are called also intraoral scans, with the doctors wants us to make some kind of restoration, but very often he doesn't know what kind of restoration would be the best restoration in this situation, in this clinical situation for the patients, which material, which solution would be the best. So we are responsible for finding that solutions. If it's screw retained or removable restorations, we have to find the proper materials to provide good aesthetic and durable of our restorations. And I would like to start with maybe a little bit boring thing, because basic mistakes, the fundamental, let's say, mistakes, but they have huge influence on our next stages of workflow. So let's start. We should eliminate the mistakes at the beginning when we get the impressions. So the most popular, they are not very often, but they can happen. We have to know why. We can get the frozen alginate impressions. It can also be dried. The impression material can be detached from the impression tray. This is the picture from just for fun, without huge comments. It's from our dental technician Facebook group. The first base of impressions, first layer, as you can see, is the pink wax. The second one is something similar to Impregum. And the funny thing is that dental technician tried to do this single crown for central incisor, and probably, as he said, it fits quite well and everything was fine and patient was very, very happy. This is not the way I think we all are planning to work with. So the next problems. I really hate the too small partial impression trays, because they provide us insufficient mapping of prosthetic area. It is very difficult to make proper occlusion also. When they are too small and too elastic, it's double evil for me. Also, it can happen when doctor doesn't have enough impression material, or it's the rest of the box. We have insufficient amount of impression material in the impression tray, so it's very, very difficult or mostly impossible to make correct gingiva profile and just create the restoration. Insufficient mapping of prosthetic area because of the too small impression tray, or insufficient amount of impression material can be a huge problem when we try to put together two models with the registration bite, because it's very difficult to remove the bubbles, the bladders, even with using microscope. We are not the wizards, the Gandalfs to create proper occlusal surface. Detachment and separation of impression material from the tray. It's very often when we use the plastic trays with the holes. I also really don't like this kind of trays. I prefer the individual ones, but it can also happen. The next problem, insufficient amount of second layer of impression material that create as double occlusal surface, and it is also very problematic with reaching proper occlusion and connecting both models together. And very, very important is the technique of making impressions. Very often, when I was younger, I had a little bit more time to go to visit my clinician in the clinic to watch how they works, because I am sure, I believe that it can also only work properly when both sides know very good what is happening on the other side. So when we know what how looks the work of our clinicians, and in the other way, that is the only way we can communicate, we can cooperate with success. So I saw many times that usually antagonist model with alginate impression material is made without any attendance. Sometimes it's made by assistant, very, very fast at the end of the appointment, because it's not such important. And from my point of view, and I hope that you agree with me, that it's the very important, such important as the main impression. And I saw many different techniques of making that alginate impressions. Sometimes the people are first aiming the parts of impression tray to the molars, because it's easy to aim and to fit it in the proper way, and then put down for the incisal part. And it's always can happen something like this when you put impression tray to the molars, you put it down to the incisor, so every time molars will goes up, and then you have empty spaces, pullings, and also whole impression is has many divergences in many directions. So it's impossible to find these mistakes, and usually we know that such mistakes happened, at the trial of the structure of final work. As we can see on the right picture, implant-supported structure with for PFM. An antagonist model, it's about 2 millimeters space to the registration bias because of the deformation of upper impression. And the very funny thing is that people sometimes hate making one extra appointment for making individual impression tray, and still are trying to use the standard one. Here you can see on the picture that in the molar area, the thickness of the impression material is very, very thin, because we can see the green impression tray here. And I am slightly touching with my finger the transfer with analog, and it's moving all around. So that's not big problem to make some distortion while we are making the model, the gingiva mask or plaster. So it's impossible for passive reconstruction. So I prefer individual trays and open trays. The second one, we have to be aware that our components has short life, maybe not very short. It depends how we care about them. It's maybe not every time single use. We can use it many times, but we have to check carefully the quality of our components. Here we have Megagen transfer, and on the right side you can see that analog is not fitting properly, and I am not sure, and I can say if it fits into the implant properly, and how do I have to work with that. So usually I send it back, and I'm asking doctor for repeating the impression with new transfer or with not broken. Also, and this was the same case, I get from my doctor an implant analog, because maybe some assistants use the hammer for removing it from the plaster model. So it is very difficult to use something like that. It's unusable right now. In many different implant systems, because we are working right now on almost 50 different implant systems. So we have some experience. In many different implant systems, you can screw transfer into the implant in not his proper position. So very often when you see the impression material between transfer and the implant, then also you should send it back to the clinic and ask for a new one. And I am also not a big fan for closed tray, because here we have some disadvantages, empty spaces when we can take out our transfer from the impressions, and then in laboratory screw analog and put it back inside. There is always some empty space, and it's usually moving a little bit. One solution for such problem is switching to digital, but is it really in every cases? In digital, when we get our optical impression, let's say, or intraoral scan, we have our scan body, and we need the library. The library is a magic word in our brand, I think, something like Saint Graal. Everyone is looking for some library for some system from some CAD software. There's always problem with some library. So here we have the Megagen, our RI 13 millimeters scan body, and we obviously need the library of this scan body. We have to match it. Our library is nothing else like virtual shape of our components. Every component we use for virtual treatment, for virtual planning and designing, and we have to have library of scan body or scan abutment. it looks like this. We also need the library of our implant, the library of our screw, library of repositionable analog for printed model. Also, second in a row, the library for sleeves for making model, because library for repositionable analog and the library for sleeve for repositionable analog is similar, but completely for something else. And here we have our printed model designed with reposition-enable analog, and we can start work. And sometimes when we think that and really strongly believe that everything is fine, it can finish like this, and we don't have any other option than switch off the computer, start again. But that's only the slide from my presentation, because the digital is not solving any problems. Anything will not make and not happening just by self. It's only a tool in the hand of dental technician or clinician, which can help us to make something faster, better, maybe cheaper. But for me, the precision is the key factor for this workflow. And we match our scan body to our library. And here we have sometimes problem that we don't know why, and it doesn't want to match together. We can try to mark a few different referential points for such process, but it's sometimes not easy. We don't know why. It happens that it's some kind of, let's say, computer bug, some kind of error problem we can't solve, and very often it helps just generating the files again from the intraoral scans. We had such situation a few times, especially with one brand, but it doesn't matter which one, but maybe it's just because of software or something similar. We match it together. Because obviously in this case it was easy. When we have metal scan bodies which are glaring, shining, or we have a lot of saliva, lots of blood on the scan body, then our intraoral scanner can not be sure what is inside the mouth and will not match the surfaces properly. It's quite obvious why, if we have two scan bodies very, very close to themselves, also when we have a scan body very close to adjacent tooth. But in this situation, we are really not able to match scan body with our library, because the empty spaces and the divergence between dimensions and shapes are, in my opinion, too big to work with some kind of precision, let's say. It's visible too much holes, too big holes, and too small reference surfaces for making the merging or matching process. We tried this case. It's also the enrich. It's the same scan. We try to do it in the tree shape in Exocad, and here we have in dental wings, and every software had the same problem. So the doctor had to repeat the scanning process. And after this problem, he said that he made some kind of upgrade of process, and one icon wasn't marked, and this marked was for scanning scan bodies or metal surfaces. So maybe in this situation, scanner didn't know what surface he should be mapping. So here on the scan bodies, we can see the spaces, the divergence, the differences between shapes and sizes of our scan body and our library. The next problem can be like here in this situation. What would you say if you look at the contact points? In my opinion, it looks quite good right now without using articulation foil. Here you have a bigger photo, and I think everyone say that everything is okay. But in the mouth, situation looks like here. It's about 1 millimeter space between our crown and between our adjacent tooth. And what happened here? Everything is okay. Scan looks perfectly fine. But in the mouth, as you can see, in the molar, we have amalgamate filling. So it's metal and it's shining while scanning. So in my opinion, when scanner is mapping the metal shiny surfaces, it's read them like a bigger, like thicker surface. So I think that's a huge problem for many techniques and many purposes with optical scanning. The problems happens also with bite registrations when we get the scans sometimes. When something happens, or because of the doctors of the hand, usually it's because of the operator fault. But sometimes we have some bugs with scanner softwares. And here we have warning. There are intersections in scan data of both jaws. We can cut it, or we can open it just a little bit, but it doesn't have anything common with proper occlusion. It's just maybe taking both models between themselves like by hands. It's very, very slight. Here you can see the differences. It's not the way we would like to work. If we make such crown, it will be always or intra occlusions, or will be too much about 1.5 millimeter too high in occlusion. So it's horrible for our clinician, and adjusting in occlusion during the very short, usually our appointment with our patients. Sometimes it's happened that we get our scans in completely wrong coordinates. It's usually because of the workflow and every proper steps of scanning. Because of the software, and usually the scans with scan bodies are uneditable, so we can move it to fit it with our occlusion and with our other scans. So our doctor has to generate the scans again from the scanner, or repeat whole process of taking optical impressions. Also, when we use intraoral scanner for making restorations with pre-op scan, there's many different names for this process, and doctor send it to us. We once get something like this from our clinician, everything in every picture in completely different coordinates. And such thing happens, but usually, as I said, it's because of the operator's fault. And here what we have, that's one of my first implant-supported restorations, made about 17 years ago. I was very proud of it. These days, not right now. I have to clarify it. The ceramic and the picture wasn't good. I didn't know these times anything about soft tissue management, about Tarnoff rules. You have the big black triangles, and the Tarnoff rules say that if we have space between contact points between our tooth and the peak of bone up to 5 millimeters, we have almost 100% of chance that our papilla will grow up and will fill the empty spaces, and black triangles will disappear. If you have 1 millimeter more, the chances decreased to half. let's say. And when we add 1 millimeter more, and the space between the bone and between the contact point will be about 7 millimeters, then you have a 27% of chance that the papilla will grow up and will close the space. So you can be sure that you will never have the papilla in this place. This was made on ankylose, balanced posterior abutments, very short, so it's high risk to decement this structure from the abutment in the mouth. Second problem is residual exudate of cement. How clinician can clean this area if the abutment is so small and the crown is so wide? It's impossible. And these days, 15 years ago, we made a lot of such restorations. In these times, we didn't have such nice solutions like individual abutments or angulating screw access abutments. We had standard options only, and we made a lot of such restorations. I am sure the most of them is still somehow working, but few of them could lead to some problem. As you can see on the scan, we have to create the big molar on the standard balanced posterior abutment. The Gingiva profile was profiled by doctor very carefully with provisional crowns, and because of the of the wide profile and very narrow abutment, and here was the goal to create the cementable crown. We can see on the screens, I don't know if the small numbers are visible for you, but it's more than 3 millimeters distance between cementation margin of the abutment to the soft tissue, our margin line of emergence profile. And it's also impossible for doctor to clean it, to diagnose if some cement exceeds in our socket. This is not my work, I must clarify it. The patient came to our doctor from Germany probably a few years ago. He made that bridge 10 or more than 10 years earlier, and he said that everything was uncemented. He asked for cleaning it and cement it again. And here we can see the huge problem with rest of the cement under the pontics and near the crowns, and completely wrongly designed the gingiva shape and the tissue contact. It's overlapping surface, so patient has huge problem to clean it. As you can see, under the bridge is almost everything, also with cement. This is phosphate cement. Some people say that phosphate cement is very proper for cementing implant-supported restoration, because the rest, the residues of phosphate cement can flow out from the socket with sulcus liquid. And here, after several years, you can see it's maybe not really true, and it's not the solution for the problem of exceeds of the cement. So me and our doctor didn't want to clean it and to cement it to the patient again. We did it just for 1 week as a temporary for making the new restorations. We explained the patient problem which can happen soon. Somehow the 3 tooth and 3 implant, it was also ankylose place in this situation. They were okay, they were fine, there wasn't any huge inflammation, but it's maybe because of lack of organism resistance, I don't know, but we have changed it completely. How can we manage such problem with residual cement? The first option is stamp abutment protocol by Paul Weigle from Frankfurt Goethe Universität. To use the stample, you have to have your crown ready to cementation. You have to check if everything is okay with contact points, with occlusion, and just before the cementation, you make the stample. You have to isolate insides of the crown with glycerin, for instance. Use some composite or pattern resin, some material which you have in your hand. Make such stample, then clean it perfectly from the glycerin. You use the cement that you usually use for cementation. You put it inside the crown and then push the stample, put stample again into the crown, and then exit of the cements you can clean with tissue. You remove the stample and try to cement it in the mouth, and inside the crown you have just slight film of cementation material. And here pops up the questions if the cement, the amount of the cement material is enough. And the research concluded that it's enough, but even if it wasn't, it is not such big problem like in situation when there is too much exit cement in the socket. But what we really love and like, and clinicians and doctors, in when our company is providing us original pre-milled blanks for in-house productions that I can make my individual abutment myself. I can design it. I don't have to use any other external design or milling center for making it. I am doing it with cooperation with my doctor. So I think I know what I need and I can provide it to myself. And I don't know why, but from almost 50 implants, 50 different implant systems right now on the market, which we are using, only few of them, are providing original blanks. It's huge market, and many producers also provides unoriginal components. I usually don't use them and I don't really like them. I prefer to use original on original, especially when I have in my portfolio original blanks for making such components. And mostly we are using individual abutments or multi-unit abutment for bigger restorations. With multi-units I can do many different cases, also with no engaging connection, which I will show you in the next steps. In short words, basically we design virtually our abutment. The pre-milled blank is mounted in the special holder in the milling machine. That is how it looks. The burrs with water cooling are milling our individual abutments, the Gingiva Profile, core high, or Gingiva high. And here you have the comparison from the case I show you at the beginning. On the right is standard abutment for ankylose, if I remember, maybe not, it doesn't matter. But you can see that the distance from the margin line and our soft tissue is more than 3 millimeters. On the left side, we are able to design it however we want. Usually we create the margin line 1.8, 1 millimeter below the soft tissue. On the lingual or palatinal, it can be 1 for 0.5 or even 0.0. It doesn't matter because it's not the aesthetic area. Approximately between the adjustments, you can do it on 0.0 or 0.5. There is no need to make it deeper. When you make the cementable restoration, it will be every time easier for clinician to clean the residual cement. Here we have the first case, which I want to show you from the intraoral scan. It's enriched. We have the impression, optical impression with our scan body. Our gingiva profile in this situation was profiled quite good, in my opinion. The soft tissue didn't have enough time to collapse. So clinicians work very, very fast, and what we have to do, we have to push it a little bit, about from this situation 0.5 millimeters to push the soft tissue, but not too much, to create better gingiva profile, better emergence profile. This is how does it looks. And when do we have such possibilities? When we have the rule of 3 millimeters. When we have for proper shaping of gingiva profile, we need to have 3 millimeters of soft tissue around the implants, 3 millimeters above the implant, and 3 millimeters of keratinized soft tissue around the implants. You can find many different similar rules. Very popular is also 3A, 2B from Dr. Fernando Rojas Vizcaya. They are a little bit different, but basically in fundamental, it's the same. We need space to create a proper gingiva profile, so we need soft tissue, and if the BMI is very important, because if someone is looking just like me, so probably we have very thick biotype, and we have enough space to push soft tissue to create it for our purpose. When we have the 21 years blonde hair lady with blue eyes, maybe it's we will have some problem with thin biotype and with pushing soft tissues. We have to be aware. We can't create too much pressure for the soft tissue and for the bone, because we have in this situation we can have situation with no zero bone loss. So it's not the case we want to finish. Okay, usually we design our individual abutments with 0.88 of the palatal side. Here is design our abutment, milled our abutment. Usually we anodize them because it looks nice, because it's gold, and gold is fine, obviously. Second thing is that anodized surface is much better for soft tissue than clean titanium, pure titanium. Also is kinda rust fried, let's say, and it's at the end the cleaning whole surface with high voltage process with any kind of residual dust or something. But basically it looks nice, and it gains proliferations of soft tissue cells. Here we have the design of our abutment, our crown, and the space for veneering material. And very important with individual abutment, we create some pressure on the gingiva, is to screw it in 2 steps. One step when you screw it, and you use the final torque, for instance 35 Newton centimeters, you can make a trial of our crown, make some kind of occlusal or contact point adjustment, wait about 10-15 minutes to look if the pressure for gingiva is not too high, and anodization, the white parts around the abutment, through that time, that 10 or 15 minutes should disappear. Then the pressure goes down, the blood will flow out from the soft tissue, and you can try to screw it again with the same final torque. And then you can notice that sometimes you can make one full or even more than one full turn of screwdriver, and then you can think that it's proper position. If you would cement the crown after the first screwing, probably it can screw out after a day or 2-3 days, and that's very, very important. And when our doctors many years ago started to make the individual abutment, we had very often that first few cases we have unscrewed after a few days because of not using the 2 steps screwing protocol, and that's really, really important. Here, obviously, because of the angulation of the implant insertion axis, we had problem with making screw retained restorations. So we made an individual titanium abutment with our beloved original pre-milled blanks. We made the PFM crown, and after this process, you have to smooth out both surfaces to each other. So take the rubber gum or first the diamond and few different kinds of rubber for polishing it, smoothing out. That we should be aware we can't leave there any gaps and any overlappings for healthy condition of our soft tissue in the future. We created our virtually our model. We printed it. We screwed it with repositionable analog, put it inside, and everything is fine. Doctor is happy, patient is happy. But our fantastic group of clinicians from Poland has made a clinical research in 2016. The monolithic zirconia crown cemented at CAD/CAM customized implant abutment showed that clinically undetected cement excess was visible on more than 73%. And basically, conclusion is that customized abutment doesn't guarantee avoidance of subgingival cement residues after crown cementation. That's very important. And also the research of Tomasz Linkevičius, I am a big fan of Tomasz Linkevičius, zero bone loss, said that dental radiographs shouldn't be considered as a reliable method for checking if we have residual cement. The problem is also because that not every cement is radio opaque and is visible in the X-rays. And the basic problem is because of the direction. When on the left picture, on the left side, let's say, you can see some residues of the cement. So if the cement would be in front of us or behind the implant, you are not able to find it. So individual abutments are not cementitis panacea for such situations, and the panacea can be screw retained restorations and eliminating cements completely in our workflow, and try to do it this way. Here we have case with single implant. We have the molar implant implanted with Enrich. And in this case, we didn't have such beautifully created Gingiva profile with provisional crown, with individualized healing abutment. So usually in dental lab, we take the burr for gingiva mask and we cut it. We have to know how thick biotype it is. we can't make too big pressure because it can lead to many big problems. That's the one thing in my laboratory which is doing only because of me, only by me. I'm sorry, only by me. I am very often talking with my doctors about shaping gingiva profiles, creating gingiva profiles, managing soft tissues, and I have the biggest knowledge for that. And that is the thing that I want to have always it on my desk, and I need to do it myself. We have created the gingiva profile. We are scanning the model, creating individual abutment with the rules that we mentioned before. Here we are planning also the PFM crown abutment. We created our crown with the space for ceramic veneering. This is our final crown. We can see the abutment in the model, and you can notice that the cementation margin line is much deeper than I mentioned before, because in this situation we are not making cementable restoration but screw retains restoration. It's the crown with a simple hole. We glue it on the model, clean it, polish it, smooth the both surface of the titanium and of the ceramic, and send it to our doctors. That's the final result. A very interesting solution, in my opinion, is the crown abutment. Direct veneering of titanium. It's sometimes very difficult because titanium with veneering is very mean sometimes. In this situation, we had the impression, also enrich implant. We created our gingiva profile, and our doctor called me and say, "What have you done? You have big hole like a volcano. I will smash the soft tissue. I will not be able to screw the crown." I was a little bit terrified with that phone, but let's say, did you try it? No, I will not try. I will smash the soft tissue. It's impossible to screw it. But somehow she screwed it, and it was there wasn't even any problem. And if you can see on the upper pictures, the photos before creating gingiva profile by me, the implant position isn't very much deeper than on the lower picture. So what I have done is only smoothing the gingiva profile. I didn't cut it too much. It's because it's kind of bulky, rough surface of soft tissue. In my opinion, it's because using treatment with PRF, and usually after PRF treatment, the surface of soft tissue looks like it is still healing, and we just smoothed it a little bit, made the crown, and created and milled crown abutment, but it's not shaped like the abutment for gluing crown, but it's the crown with the shape reduced just for veneering with ceramic. On the left side, the lower picture, it's case oxide layers. It's a very mean layer of the titanium, very specific for this material. And very often it happens that through the veneerings, some bubbles in ceramics comes up when we are taking out the crown from the ceramic furnace. You can see a whole process, whole steps of firing ceramic for the titanium. But the big advantage for this is that we don't have to glue the crown to the abutment. It's very smooth surface between abutment and the crown. You don't have any gaps, any spaces for rest of food, for any kind of bacteria, and you have to be aware only that that ceramic veneering for titanium, it's a little bit problematic. Not every ceramic producer is releasing still ceramic for titanium. The next case, at first look, it looks really simple, but the axis of implant position is not quite good for our restorations. The patient was also a doctor, a dentist, so we had quite problem to how to make good restoration for her, to provide good aesthetics and function and cleaning according to zero bone loss concept. We created our Gingiva Profile, but the implant was placed very, very deep, so we had bone all around, so our Gingiva Profile should be as wide as possible. This doctor didn't want to have cemented crown because of cement and zero bone loss concept. So we decided these days to use screw retained option with hole from the palatinal side, and it looks like this. Maybe it's not the best option you should expect from your doctor as a patient or your technician, but we decided such ways, and I think it's very, very safe for the soft tissue in the implant. Here you can see how deep the implant was placed. In this way, in this situation, we created our restoration with subgingival profile with pure zirconia and removing the glaze from the surface of ceramic. That's the final restoration. And here you can see that angle is about 45 degrees. So even if these days we would be able to use angulated screw access abutment, probably it would be not enough to cover the 45 degrees requirements for screwing, because usually angulated screws are up to 20, maximum 25 degrees. So that is not maybe the highest aesthetics that you can reach from the implant restorations, but after covering composite, it looks quite good, and it's still healthy without residues of the cement. Here we have a very, very difficult case for us. Single incisor, young lady after car accident. She had all six teeth, all six front upper teeth on the asphalt after car accident. So the tooth was reimplanted immediately. The right canine was lost and was implanted and provided with the provisional crown. On the central incisor, doctor made immediate implantation after tooth extraction. We created a little bit with bare gingiva profile, but because of the axis of the insertion of the implant, we was forced to make our provisional crown with the whole of the palatinal side. It wasn't a huge problem because it's only provisional at first. And the second thing is that after closing it composite, the hole wasn't visible. After 4 months, we had we have shaped our Gingiva Profile. We shaped it a little bit more, choose the color, and here with help comes up our new components R2 RC base, and soon R2 UC abutment will be available. And when I say it in my lab to our employees, let's say some case with RC base or R2 UC, they say what R2D2, and it's kind of problem to remember this name. It's unusual, and very, very unusual is also that our RC base abutment are angled. Usually when we have in different implant system angled abutments, no, straight abutment with angled screws and angled screw access, the abutments are straight. Here the big advantage is that we have also 11 degrees and 22 degrees angulation of the abutment, because it's obvious that if we want to angulate the screw, also the abutment should be angulated. And this is how does it looks. It isn't similar to anything what you know on the market so far, because of the screw. It's Roman screw with double threads. You can't put it to the implant, to the abutment from the traditional way, from the crown side. You have to put it from downstairs, like here on the movie. I hope everything will be visible enough. The easiest way is to put the screwdriver from the top side and put the screw to the screwdriver and anti-clockwise, turning it into abutment. It looks a little bit weird at first time only when you see it, because it's completely different than something else, than something that you know from your practice. Then when you hide the screw for the first tension, you are screwing it, put it back to the implant, screw it with 20 Newton centimeters, and that is very important. You can't use the force 35 Newton centimeters. Only 20 Newtons is enough for screwing it. That is how it looks. And
also, sorry, Arek, to interrupt, but I think one of the really interesting points that when you're doing the crown, you don't need to make a huge access hole for to remove the abutment screw, because it's just only the abutment removal driver.
Yeah, of course. That's very, very important, especially in the front region area. And you don't have to push palatinal that crown so much to cover the need of removal the screw. So I agree, that's very important. Okay, and again, we are creating our crown with the space for our veneering. We have planned here the zirconia crown. We didn't have enough space, enough soft tissue to make a whole zirconia gingiva profile, so we made it with ceramic. Here you can see the angulation of insertion axis of the implant was huge, and here the screw is just near the incisal edge, the whole screw. The abutment is quite small, so we don't make too big pressure for the soft tissue. We create our crown, we design our crown, but the problem is that the crown is so big and the abutment is so small and so short. And usually the producers says that the abutment doesn't require of sandblasting the surface of the abutment. And here we can see the Dentsply Atlantis abutment for Astra. It's Astra EV probably. And I have tried this protocol. I took this abutment from milling center. I didn't sandblast it. I only used the steamer for cleaning. I glue it, and next day patient came back with uncemented crown. Inside you can see the Teflon tape. After ungluing, I decided to change that protocol. I sandblasted it. I made some cuts on the abutment and inside the crowns with very, very tiny diamond disc. and use the Bredent DTK Kleber for gluing. And that is the protocol I use mostly, but I was considering another options, and I was following the researchers, for instance, from Tomasz Linkevičius. But the results and the conclusions were not satisfying for me. I couldn't understand how is it possible that it's quite obvious that the cement type had a significant influence on the retention of the zirconia copings, but the abrading the titanium bases with aluminum powder with sand significantly decreased the dislodging force of the coping from the titanium base. It's something completely different that I have observed in my daily practice, and the other many other researchers here, for instance, Irena Seiler, Vincent Femer, Pita Burkhardt said this. The conclusion is that sandblasting it with the 50 micron aluminum oxide provide the most stable bonded interface among the tested methods, and I am choosing this protocol for my daily practice. So I am cutting. I'm making some threads, some cuts on the abutment and inside the crown, especially when I have zirconia or PMMA crown. Maybe it doesn't look professional, it doesn't look beautifully on the picture, but in the end, you have to stay on the crown, have to stay on the abutment, let's say forever. It's a huge problem when patients comes back to the clinic after a few 3 or 5 days, doesn't matter, with uncemented crown, and it's quite new restoration, and there shouldn't be such situation with such problem. That's our final restoration. With we left the space for tissue grafting. And the clinical research from Wallander, Abrahamson, Berglund claims that the titanium is the best material that you can be placed into the titanium implant. So basically, titanium connected with titanium is the best solution. I am not a big fan of fully zirconia abutment or something like something else. Even the chrome cobalt abutment, which are very popular sometimes in the world because of the possibility of the direct veneering of ceramic onto abutment. I am using only titanium as the material for making abutments, but zirconia oxide and I forgot the name. Doesn't matter, but Emax, Lisi, or Celtra, for instance, are the best materials for the stability, and titanium. I'm sorry, titanium for stability of our soft tissue, and feldspathic ceramic resins, and even the gold alloys sometimes are not biocompatible with our soft tissue. So the best what you can do is to place the highly polished surface of the zirconia in contact with soft tissue. And if you don't have such possibilities, after glazing the crown, you should remove the rest of the glaze from the tissue contact areas, because glaze is very, very fine powder of clear mixed with borax. Borax is used in glaze as a flux, which have to decrease our glazing temperature, and borax is highly allergenic. So this little amount of borax sometimes can make inflammation or something similar to our patients. So if we can, we leave polished zirconia. If we are not able to do it, we just have to remove the glaze and polish it on the high gloss in that area. Okay, here is the final crown. We have another case with R2UC, 2 premolars implanted and healed without individual provisional abutment. So we had to create the Gingiva profile in laboratory with the burr. The insertion axis show us that we will have slight problem with making screw retain restoration on the first premolar. We created Gingiva profile, created our individual abutment on the second molar, created the structure. Here we can see the individual abutment designed in very, very limited space with at the occlusal area. We created our crown. The crown were splinted. Here is the final effect. And what we used here, it was the individual abutment on the second premolar and R2UC abutment on the first premolar. The very important is when you send job to your clinician and use some different components with different screwdriver, it's very important to mark it on the model, because at the first step, doctor will take the classic screwdriver and will try to screw it out, so can damage the screw or screwdriver. It's very, very important to remember about it. That's our final restoration with stock R2UC abutment on the first premolar, individual abutment with no engaging connection, only the cone on the second molar. According to Zero Bone Loss by Thomas Linkevicius and his great book, it's not problem to mix that and connect that components. Some people say that when you are making bridge, you can't mix and you can't fix the 2 abutment with engaging parts and with no engaging parts. Usually it's not the issue. You have the model, you have your restoration, you can check the passivity and how does it work. You can do also next thing, which I will show you right now. Here is very similar case. We want to have a 3-point bridge. Also, Gingiva profile is not profiled by the doctor, by the clinician, so we have to do it ourselves. And also the insertion axis of the implant on first premolar is a little bit problematic for making screw retain restoration. So here we will use RC base for premolar and for molar individual abutment. This is how it looks. It's milled design. This is how it looks on the model. We created our structure for 6 size zirconia veneering. When we design abutment and we have enough space, enough, let's say 3 millimeter rule of soft tissue, we can design on this stage abutment with emergence profile made of pure zirconia. This is our final restoration. Structure on the model. This is after veneering. And here, if you can see on the, it doesn't work. Okay, you can look at the connection of the abutments because it was engaging connections in both abutments, and because of the divergence, slight but divergence of the implant axis, it was problem to fit it on the model. Then we could use no engaging individual abutment on the molar, or cut it a little bit. It's not big problem. You can do it by burr, then polish it. You have to be aware and do it carefully with attendance, because you can't touch the cone. You can cut the hex, the engaging part, but the cone is signed for us and we can't even touch it. This is how it looks. The zirconia polished gingiva profile is the best for our tissue, what you can provide. Also, I am making the cuts. I am sandblasting the abutment and zirconia crowns inside, gluing it. And when we consider the gingiva profile for pontics, the worst what you can do is the ridge lap, like 1A on the left. It's huge problem for cleaning for the patients. Sometimes it can look the best because it's long enough to provide correct zenith of our crown and adjustment teeth. It can look good, but the cleaning and the function, it's completely another story. You can make that evil a little bit later when you modify that ridge lap and you will cut the palatinal side of this lap. Then it's a little bit better and sometimes it's acceptable with perfect hygienic patient. The best what we could create is 1C. It's full ovate pontic, let's say, but we need to have thick enough biotype, aware technician, aware doctors, how we should manage that the soft tissue, because if we will create such big gingiva profile, we will not be able to screw the restoration. So we have to prepare it before by provisionals or through the surgery. And the most often when we create gingiva profile is like 1D modified ovate pontic with slight pressure and mostly from the palatinal to create something like papilla, and we follow the rule in this situation. I want to show you one case, which is not my case, it's case of my friend. She's a doctor. She sent it to me. She made it in another lab. She sent it to me with ask for evaluating the problem. And here you can see its gap. The gingiva profile wasn't created at all. So at the first look, that's the biggest problem for me. But for her, here was the biggest problem, that it was the space between abutment and the crown. So probably the crown was too tight. There wasn't enough space for the cement, and through the cementation, cement couldn't go out from the abutment, and the position is too high. But please look on the gingiva profile. It's rough. It's bulky, not smooth. The residues of the cement everywhere. So it's huge problem and have nothing common with zero bone loss concept. This is how it looks. It's the rest of the blood, it's some kind of dirt, it's horrible for me. But the same patient, the crown in lower jaw, it's designed without contact point. Okay, I agree. But at the end, the gingiva profile is quite good. Even the highly polished zirconia surface. The huge problem is the rest, the dirt of something black on the threads of the screw, and unoriginal abutment. Here is Straumann BLT in this case, which is also not fine solution for me. The worst thing I saw as a abutment evaluator, let's say, it's casted one with some holes, with some bubbles. I don't know who created it, but it's impossible to put it precisely in the implant and cover the ceiling between implant and abutment is horrible, and you should never give it to your patient. Okay, we'll switch to just a little bit cases right now. Here we have some very nice lady with toothless upper jaw, implanted with 4 enriched implants on canines and, let's say, first molar area. And on the first stage, we made a wax ring test. On the second stage, second appointment, we prepared for our doctor the setup teeth in a wax. And on the third appointment, we created a trine, printed trine, full anatomic for making pictures, checking the occlusion and registrations. And on this stage, we also provided to our doctor the provisional bridge with created ovate pontic, let's say. Here is how it looks. We chose in this situation enriched octa abutment because the axis of the insertion of the implant was quite good, and we didn't need to angulate the screw holes. We cut our gingiva mask slightly to create ovate pontic. Our try-in has to be as good as possible, but it doesn't have to create and doesn't have to shape our soft tissue, because then we need time to push it in the mouth. It has to be fast and easy, so doctor has to take it from the model, put it in the mouth, screw, make the pictures, make the registration bite, or because it's soft material, any kind of occlusal adjustments are very, very easy. This is how it look in the mouth. We get the picture from our doctor, and on this stage, doctor provided patient with provisional bridge. On the upper pictures, you can see just after the loading, and on the lower picture is 1 week later, so you can see the difference, how beautifully the soft tissue and the papilla was shaped between the incisors. It's provisional, made very, very easy and very fast, and looks almost like a natural teeth. After removing on the next appointment, we can see that ovate pontics, the shapes of our gingiva profile are profiled quite nice. From this level, we repeat the impression with individual tray from our enriched octa abutment level. This is how does it looks. It's very important to make in our individual tray the chimneys trace, that impression material can cover whole transfer and doesn't move in the impression. And from this stage, we are working not on the abutment, but on analog of octa abutment. This is how it looks. You can see that after the impressions, our gingiva profile and soft tissue collapse a little bit. So we have to grind it, cut the gingiva mask again a little bit. We designed the shapes and designed the metal structure for veneering ceramic. And very important is also to make the Sheffield tests, which are also called sometimes single screw test. If you are putting it to the mouth, you use only one screw to screw whole restoration, and you use one screw it on the one molar, for instance, and when you can see that all of the rest of the structure is sitting on the abutment, then you can say that Sheffield test is passed, that structure is passive, will not have any tensions on abutment and implants, and you can go forward with other steps. So you can screw it out, screw in this situation the abutment on canine, check the passivity. If everything is okay, you do it exactly the same with single screw on every implant. If something is wrong, you have to repeat the impression and repeat the structure. You can't leave it just like that and go forward with next steps. So after veneering, it looks like this. Just for picture, the octa abutment are screwed to the bridge. Gingiva profile is created without need of using pink ceramic, and that was the main goal. The main goal. We created everywhere O8 pontics, and gingiva profile surfaces which has contact with gingiva were polished to remove residual borax in glaze for better and healthy soft tissue. Oh, I forgot the words. And this is how it looks on the model. We can see that papilla looks quite fine, but that's only the model. We are wondering how that will look in the mouth. Still the pictures on the model. We didn't have the problem with angulated screw, so we could leave it like that. And that's the day of delivery. Of the loading of the restorations. We can see that after removing provisional bridge, the papilla looks still quite stable, and after loading with the final restoration, it's quite okay. Patient is very, very happy. That's after 1 week, you can see how papillas looks without pink ceramic. It's necessary in this stage, and very often people think that if we make all on 4, all on 6 case, we have to create it with pink ceramic. It's not true. You can do it without it, just making O8 pontics, creating gingiva profiles, and it can also looks quite nice. Here we have the picture, 4 years follow-up so far. Patient still happy. Soft tissue is still happy and still healthy, maybe also happy, but mainly still healthy. And another very similar case on the lower jaw, also 6 implant placed. In this case, we decided to use multi-unit abutment. And one more thing, why octa abutments? In some cases could be better than multi-unit abutment. It's because of the width, of the dimension. It's much more narrow than the multi-unit. So when we have our implants placed very, very deep, very subcrestally, and we have very thick biotype, and then there is a risk that we can push our soft tissue or bone too much with the multi-unit abutment. Then maybe we can use the octa. It's much narrower, so maybe it would be better choice. In this situation, we use multi-unit abutments. It's very important to remember about the torque. I will show you later how it could end when we forget about it. The anglet anglet abutment, you can screw with 25 Newton centimeters. The straight one, let's say in the middle of the picture, is 35 Newton centimeter. And very important that you need the special screwdriver. I am not sure if it's in the basic kit of the surgical kit, but you have to order it. It looks like a pipe or something, but without it you can't screw it directly to the implant. And in the catalog, when you will make some research, many different kinds of abutment have different torque value Newton centimeters. So you have to be aware that that is very, very important, especially when you are using mini Enrich. A few days ago, we have a situation with mini Enrich. We made an individual crown for lower incisor, and the doctor said that the screw has just broke when I was trying to screw it, but he said that it broke only at 25 Newton centimeters. It should last up to 35, and 25 is the problem. And I remind him that Eneridge Mini needs only maximum 15 Newton centimeters of torque. So that's very important to check it every time when you see some new components, or you are trying to test some new kind of solution, that you have to be aware of the correct torque value. And in this case, we use 6 multi-unit abutment with 3 different gingiva height and our specific screwdriver for this. This is how it looks on the model with gingiva mask. On gingiva mask, we have created ovate pontics. Here we have very difficult situation with occlusion, with relation between upper and lower jaw, what you will be able to notice. The front teeth should be pushed out palatinally as much as possible. And on the trial, the doctor has slight problem because of the 2 front implants. They were placed very, very deep, and abutments were a little bit too wide, and they were pushing gingiva. So he asked us to cut it a little bit. We made it a little bit more narrow. We smoothed out the 2 surfaces together, the surface of the bridge and surface of the abutment. And usually we do it very often in this stage because it was the straight abutment. We just forgot about it. And in many different different implant system, especially with anglet multi-unit abutment, they are edges, shapes which are not necessary for our treatment. So we take the burr, we take the gum polish paste, and we make it much more smooth than we get it from the factory. Here you can see how the bridge is designed, especially in the front area. It almost comes up from the ridge to the palatinal side. This is how we made the multi-unit a little bit more narrow. This is the final restoration after veneering. And because of the insertion axis, it wasn't necessary to use anglet multi-unit abutment, so it was quite nice case in this situation. This is how it looks. We used the modified ovate pontic, so the doctor have to also be aware that such big case with many pontics will not be able to push it to the gingiva. It just screw to the implant. Sometimes it needs 20 up to 30 minutes to pushing it slightly, a little bit, waiting when the blood will comes out from the soft tissue, and the emergence profile will be created by our final restoration. And it needs time, patience, and awareness of such process. The bridge was milled cut-cam from the level of multi-units, and I like this system very much because we also are able to use original components, original scan bodies and libraries from the multi-unit implant level, original screws, and mill it in my lab to provide my quality, let's say. And I am sure that every step in my lab are made by with my knowledge, with my care. This is how it looks. And the last case I would like to show you is a lady with such initial situation. In upper jaw, we had some plastic-like bridge with some kind of gingiva, vertical root fractures, and hopeless tooth So everything was removed. 6 implants were placed as immediate implantation. The doctor, through the surgical part, chose the multi-unit abutment, placed it in the mouth. Everything was sutured. He made an impression for not immediate loading but early loading. We create the restoration, and before 48 hours it was placed in the mouth. The situation, the occlusal situation was very difficult. The upper jaw was much more narrow, were smaller, much smaller than lower jaw. The patient didn't like us, probably, were maybe a little bit mean, and every bite registration we were completely different. And through every process of making the final restoration, we have always problem with occlusal registrations. We made it 2-3 times, trials, adjustments, corrections to make the final restoration. That's the temporary restoration delivered 48 hours after surgery, as early loading, early temporary loading, only for front implants. Because of the difficult bone condition and lack of primary stabilization, the distal implants were covered for healing. Here is a situation after 3 or 4 months, probably, after healing. The temporary bridge was taken out. The impression was repeated, impression from the abutment level. Here is also very important to create our impression tray with chimneys, as I mentioned before, that all dimension of transfer can be covered with impression material. This is how our gingiva profile, our soft tissue, looks on the model. In this stage, we created our try-in, like we do it usually, and we send it to the clinician to check the occlusion, to make the pictures, and you can see that's not the best what patient could get on this stage. But we had huge problem with registration. Every bites were different from the previous one. On this first stage, this was the first try-in. Doctor cut the teeth, shorten it, made the marks with smile line, with midline, and we make the second one. After adjusting the occlusion registration with bite, I prefer silicone, hard silicone for occlusal registration. I don't like wax. I prefer Registrado from Voco or O-bite or something similar, very hard material. Connecting it with pre-op, which we made from our try-in. We created zirconia structure for veneering. We use the titanium sleeves. You can't use zirconia screwing directly into multi-unit abutment. It always has to be glued onto titanium sleeve and screw on the abutment. This is how it looks from the occlusal side, the milled structure on the model. And very important here is the all slides from before, from creating ovate ponting. When we don't use glass ceramic, is everything okay? When we use pink ceramic for gingiva, everything is okay. But in bigger cases, when we have atrophic situation with the bone, with our soft tissue, and we need to use to create artificial gingiva, we have another approach, let's say. also in this situation, the worst what you can do is the ridge lap, like on the left side. It sometimes can look okay because you can push it palatinally, support soft tissue, so the aesthetic effect can be very, very okay, but functional and cleaning, it's horrible. On the middle photo, you can see that cleaning is okay when you create ovate pontic, and that would be very, very acceptable. Only a small part can be, let's say, adjusted, can be made better, because when you smooth out and connect two surfaces of gingiva and of artificial gingiva of our restoration, there is always some kind of gap, like here you can see on the palatinal side of the borderline of the connection of the two materials. So right now we are making it flat contact as the most correct, most proper shape. There is no problem with cleaning, and it's beautiful shaping and smoothing with our natural soft tissue in the mouth. So we created it on the model. I took the burr and cut a little bit our artificial soft tissue, our gingiva mask, and veneer it with ceramic. Afterwards, I polished the soft tissue contact I removed the glaze and leave it high polished with just rubber and polish paste. We glued the titanium sleeve with the protocol that you know. I sandblasted it, made the cuts, and everything was smooth. Gingiva profile, when you are making single crown or bridges without pink gingiva, should look like you take an egg, put it into the plastiline, take the egg out, and you have beautifully shaped emergence profile. That's the easiest way to describe it. When you create the gingiva profile for veneering with artificial pink gingiva, the best you can do is the flat connection. And why am I talking so much about it on our courses and lectures or something else? It's very, very important, because on the market there is an insufficient amount of good training, of good books. Maybe right now it's a little bit better, it's changed, but many years ago I were on the Congress for dental technician, and one, let's say, seller was advertising new material from Aman Girbach that you know probably. It's called Ceramil Silicon HT for huge restoration, and they showed something like this. And it's okay that the surface of soft tissue was polished zirconia on high gloss. It was very, very okay. But look what is the shape, how looks the shape of whole restoration. It's overlapping the ridge lap on whole area of the connection between the restoration and soft tissue, and patient will not be able to clean it. So if such big concern shows us such restorations, then technicians tries, or even clinicians tries to follow such things. So that's, from my opinion, completely stupidity, and I am talking it very, very often. Sometimes you can be bored with that, but I think it's better that you are bored with me talking 15 times the same than once I forgot to mention about it, and some patient will get such restoration as a final restoration. So we made some cuts inside with diamond disc. We glue it on the model. That's the final restoration in the mouth. Maybe the effect could be a little bit better, but patient wanted to have a little bit brighter smile than before. She promised us to make whitening on the teeth whitening process on the lower jaw, but you can see in the upper jaw how looks the gingiva and gingiva profile in this situation when we have a lot of pink gingiva in our bridge. That's the final outcome. Patient was very happy, and in this stage we had huge problem with the screws, because after with temporary bridge everything was okay, and after loading of final restoration, doctor said that Arek, something is wrong, probably the restoration is not fitting properly on 2, maybe 3 implants, because I can't screw it with 35 newtons. What? 35 newtons with such small screw? Okay, forget about it. You should use only 15 newton centimeters, and 4 of 6 screw looks like this, was completely damaged. The threads was cut, was damaged, and we had to replace 2 multi-unit abutment, because inside threads of the multi-unit were also damaged. So that is very important, and that's a message from me to read your catalog and contact your distributor or sales manager. They will help you if something is wrong, and if something doesn't work, usually, not always, but usually it's the operator hands. So thank you very much for your kind attention.
Thank you, Arek, so much for your interesting presentation, and at the same time, it was very easy to follow it, and even I understand everything what you spoke. So that means if I understand, that means everybody will understand as well. So
I'm sorry for my English. It was the first time when I was providing English lectures, so I was stressed a little bit. But I will get better, I promise.
No worries. So we received several questions from the audience. Mm-hmm. Maybe Thomas, first of all, maybe you have several questions from your side.
Yeah, I thank you very much for a very good presentation, because usually technicians, show like veneers, some huge aesthetic things, with really little information for the clinician, because I really think that was very good presentation, because it's clear, because it's simple, and you talk about simple things which really matter in everyday practice. So I have a few questions from myself, but before that, I'm going to address what you just talked about, sandblasting of tie bases and abutments, and you mentioned the study which we did, and indeed it's controversial because studies say different things, but I think here the main point is that we were using tie bases, and tie bases are not abutments. Tie bases have these small undercuts, which if you blast, you make them dull, you make them not sharp, and actually you are increasing the space for cement, and this makes them less retentive. Mm-hmm. And there are studies which actually really replicate the results which we did. So here, my advice is the only one, because I am, my, let's say, protocol and my lab, we did not sandblast our tie bases for like 6-7 years. I didn't have any, just single decementation. So I always say, if you have problems, change. If you don't have any issues, so don't change anything.
Don't touch it, yeah.
Just work like this. No, there is no single truth here. And from technical point of view, I have one question about, I really liked, because I really had it in my case, the open contact with scanning. Like you scan good on the model, and then there is a gap mesodistally in the mouth.
Mhm.
So as I understood, you say that if it's amalgam or some metal, so what would be your recommendation? I mean, if I have a contact in my patient with amalgam, so
Mhm.
what should I do? Is
At
there?
first, I know the question. I understand it. The new type of intraoral scanner, let's say, and new software can have special option when you can click and the scanner knows that you are scanning the problematic area with metal surfaces. That's one solution. And the other is just taking some talc of occlusal spray and spray it in the mouth. It's not the highest pleasure for the patient, but he will survive, and I think scan will be more precise.
Yeah. Okay, thank you. Thank you very much. And once more, congratulations on very practical and good presentation.
Thank you very much.
Thank you, Thomas. So we have several questions about, wait a second. After ceramic veneering of metal framework, how do you deal with oxidation in the connection between octa abutment and metal ceramics?
Between octa abutment and metal ceramic, usually it depends on the chrome cobalt material which you use. Usually it's enough to use glass pearl, about 2-3 bar, glass pearl 50 microns, and just to clean it with glass pearl. It's polishing, airborne polishing with glass pearl. If it doesn't help and the oxides layer is too thick, then at first we use aluminum oxide, but very low pressure, like 1.5, maximum 2 bars, and slightly remove the oxide. And afterwards we use glass pearl, 2-3 bars pressures, and polish it. It doesn't have to be very shiny. It just have to be clean and precise enough to provide tight connection and sealing connection. Oh, I forgot the word.
That's okay, no stress on it. When doing zirconia framework on multi-unit abutments, when does titanium sleeve cementation happen? Before ceramic or after ceramic? And if after veneering, how do you seat the framework on the model during ceramic placement steps?
Once more, when doing zirconia framework on multi-unit model, when does cementation happen? You can do it twice. At first, you can glue it to the pure structure, send it to your clinician to make trial, registration bite, Sheffield test, and check if everything is okay. But because if something is wrong, and you will spend many hours for beautiful veneering, everything will be useless if structure is not passive. So you can check it with pure structure, and if everything is okay after the trial, you get it back to your lab, and to de-cementate titanium sleeve from the bridge, you have to put it to the ceramic furnace about 420 degrees, about 15 minutes, and then you can slightly not using a hammer, but something much smaller, knock it out from the bridge, sandblast it from oxide, or use the glass pearls to make it clean. And of course, for veneering ceramic, you don't need and you can't have titanium sleeve in the bridge. You glue it after the glazing, after when every process with ceramic are done, then you glue it on the model. also for providing absolutely passive fit, doctor can glue it in the mouth, but in the mouth there is blood, saliva. Doctor needs to spend more time for that, so they don't like it. They will not do it probably. So usually the technician makes it on the model, and that's how it works.
Okay, thank you. What kind of ceramic you use with titanium?
So far we've been using dense ply dead ray Duceram Kiss. No, it was Duceratin Kiss, but I hate this company right now because they found out that not too many people are buying it, and it's useless. They don't make enough money from this product. They removed it from the market. So right now we are not veneering titanium. We are looking new ceramic. I know that GC has titanium ceramic, and probably something else, but there is very, very few companies which are providing titanium ceramic on the market.
The next one, what is the solution you use for anodization?
I did it myself. Basically, you need some kind of transformator up to 120 volts. The titanium is beautiful anodizing for different colors. Green, blue, yellow, pink, it's not problem. It's useless for us because the best for soft tissue is the gold color. We tried with the pink because we thought that pink abutment and pink soft tissue on pink abutment will look better, but it was grayish too dark, so it doesn't have to pink. It has to be gold because pink soft tissue has to look beautifully on our abutment, and that is all. You can buy ready set from Zirkonzahn, probably. It's not very, very cheap, but for such little equipment, but you can make it yourself. Please find it on the YouTube. It's named High Voltage Process of Anodizating Titanium, and you will do it yourself for I don't know, maybe 500 euro.
Okay. Arek, do you speak in Russian language?
Yeah, of course. Oh,
Okay.
Japanese, no problem.
Oh,
No, unfortunately, no. I speak with Polish and just a little bit in English, as you can hear. So
there is a question. Если два импланта делать мостом или отдельные коронки? So the question is, if you have two implants in the frontal, in the molars and premolars, are you doing this as the bridge or as the single crown?
depends on the laboratory card, because I do it for the doctor, and doctor should know if everything is okay, if the stabilization is okay, if implants are long or maybe very short, and there was a problem with stabilization, with bone condition. Then I usually, if I don't have such information, I ask the doctor what he prefers in this situation, because if I will splint it, then he will tell me, oh, I wanted solo crown. If I will make solo crown, oh, yeah, I wanted splinted because there was problem with stabilization. So I always ask the doctor, because every option can be wrong. So you have to clarify.
Okay, thank you. And
finally, that's not my choice.
Yeah.
If everything is okay, I would prefer to do it solo, because our teeth also are as solo crown. They are not connected and splinted. So if everything is okay, I would prefer make solo crown.
Okay, the next one. Если импланты мостом, сколько оставляют промежутка для чистки зубов? So if the implant is like crown bridge, what's the space that you need to leave for the cleaning of the teeth or for the hygiene, as I understand this question?
You have to translate it once more.
So if you have not single crowns, but a bridge, how much space you need to leave to clean the teeth?
That's a very good question, because I have found many different opinions. One of them, it's leaving the space from a little brush, but I am not a big fan of that, because when you create good restoration with high polished titanium or zirconia, then hemidisposomal connection will comes up, and soft tissue will grow to the surface of our restoration, and then cleaning, mechanical cleaning, will always break up that connection, and that connection is a natural sealing of that space. When everything is okay, you don't need to brush it and clean it mechanically. You can use water pick for just like very mini karcher for teeth. You can clean it, and I think it's enough. So usually we don't leave space and distance between pontic and ridge and soft tissue.
And last one is why you didn't use titanium frame for edentulous cases?
Why I didn't use titanium frame?
Yeah, for the edentulous cases. Like a titanium bar or something like that. I don't know.
Because it was there was quite good condition, enough implant and enough bone to make it as screw retained. And screw retained restoration are usually much more comfortable for patients. I agree that if we have a problem, if we have patient who forgot regularly about cleaning, and the hygienic is very poor, then usually I prefer to do it as removable, or when we have huge atrophy of soft tissue, of bone, when we have to push it palatinally and buccally. Buccally and support soft tissue, then removable is okay. In this case, because of the patient's demandings and doctors, so I think that it wasn't the issue for making removables in this situation. Okay. But I agree, we usually in a month we made about 8-12 per month cases with bars, with removal cases.
Okay. And what material do you use for the gingival mask?
For gingiva mask, I love material which is called, it is from Picodent. It has to be gingiva mask for implant, because it's much harder and it's easier to grind it with a burr, and it's Michelangelo, Majestic, something like that. But if you will choose the implant mask from Picodent, it will be that what you need.
All right. So thank you so much, Arek, for all of the answers. We're running out of time. So Thomas or Sean, if you have anything to say, so welcome all of you.
I just want to say thank you so much, Arek. It was a really informative lecture. It was a pleasure to listen to you. Your English is excellent, good enough for us all to understand everything you want to say.
You are kind as always. Thank you very much.
No, it's true. I understood everything. And I want to say thank you also to Thomas for giving us the link between the dentist and between the clinician and the technician, which I think is always a very important part. So thanks both for giving us your time. It was really a really nice way to spend the Friday morning, actually. Thanks, guys. Thank you.
And I also want to thank Arkadiusz for a great lecture. And indeed, I'm very happy because he will be lecturing in Vilnius. Let's hope it will happen in October 22, 23. So I think that all Lithuanian participants who are listening, so yeah, he will be one of our keynote speakers. Thank you for good lecture, and see you in Vilnius then.
Yeah.
Thank you very much.
Okay. Bye-bye.
Thank you all the speakers. Thank Sean for your nice words to Arik. So thanks again. Stay safe, stay healthy. Thank you, Arik, once again. I just love your cases, love your presentation, and see you next time then.
Thank you. Have a nice weekend. See ya. Bye.